In this module of Chapter 2 on life tables, Module 2.4, I will cover period life table concepts and construction. Period life tables, also referred to as current life tables, are cross-sectional and thus represent the patterns of survival and mortality during a specific limited time period. A period life table assumes a hypothetical synthetic cohort subject throughout its lifetime to the age-specific mortality rates prevailing for the actual population over a specified period. The synthetic aspect of a period life table is that it assumes that a birth cohort of, say, 100,000, whose last members died at, say, age 115, would be subject to those same rates for all 115 years of the cohort's life. The period life table is constructed using cross-sectional mortality data for each age to compute age-specific survival px, and in turn to iteratively calculate a survival schedule including either nx or lx. This schedule is then used to compute all of the remaining life table parameters. Consider cross-sectional survey data that are gathered for a population in 2020 and 2021. In 2020, each age class from 0 through 100 contains a number of individuals, each of which is a member of a different birth cohort. Those in age class 0, the newborn, are in the 2020 birth cohort. Those in age class 1 are in the birth cohort of 2019, and the centenarians in 2020 are survivors from the 1920 birth cohort. In 2021, the same age classes are present, but consist of the survivors from 2020. Thus, the 1-year-olds of 2021 are the survivors from the newborn of 2020, and the centenarians of 2021 are the survivors of the 99-year-olds from 2020. In short, the survival rates from one age class to the next, from 2020 to 2021, constitute the cross-sectional survival data set representing the prevailing survival rates px for 2020 over all age classes. Recall that the formula for px equals lx plus 1 over lx. Cross-multiplying and rearranging yields the formula lx plus 1 equals the product of px and lx. Given that the radix equals 1 or 100,000, using the survey data we could compute the lx schedule for this population using this information. For example, L1 equals the product of P naught and the radix, 1.0. Then iteratively, L2 equals the product of P1 and the value of L1 that we just computed, and so forth. This concept captures the computational essence of the period life table. As I noted earlier, a period life table is constructed by creating a hypothetical birth cohort of 100,000. Survival of these individuals is then projected forward to create a synthetic cohort using the prevailing age-specific survival rates applied to the iterative equation nx plus 1 equals the product of px and nx, where x is age and n denotes the age interval. For example, survival probabilities from 0 to 5 and from 10 to 15 are denoted by the respective notations given here. Example computations for values of nx are given here. Thus, survival from 0 to 5 is given as 0.99482 times 100,000 or 99,482. Survival from 5 to 10 is given as the product of 0.99944 and 99,482 or 99,426, and so forth. Once the nx column is complete, all additional columns of the life table can be completed according to the formula presented by the cohort life table earlier. That is, the parameters lx, qx, dx, and ex. In summary, a period life table is based on the assumption of a hypothetical birth cohort subject to the age-specific rates observed in a population over a single period. The hypothetical cohort is considered synthetic because the survival, expectation of life, and other life table parameters are the outcome of the assumption that the theoretical newborn cohort is subject to each of the age-specific rates as individuals are survived forward. This completes Module 2.4. In the next module, I will cover the construction of abridged life tables based on lumped age classes rather than on single ages.